Good morning, guys. Welcome to the first date of the fourth quarter. Now, one thing to keep in mind before we begin is that due to the situation, I'm going to heavily weigh the homework that you do these next couple of weeks. So make sure you do them properly. Make sure you send them on time. I've already given a couple of you guys and gals a chance. I'm only giving one chance per student. I'm writing down the names if they're posted online. So just make sure you take this very seriously, okay? Because again, we need to work properly during this time. Now, first of all, in the last homework that you guys did, there were many questions about how to do the table properly. And normally in a test, I'm not gonna probably ask you for a table, but let's go over one of the examples of how to do the table in case I do ask it one day. Now, let's say you're given a particular polynomial, and when you evaluate the positive x's, you get a total of, let's say, 4 sign changes. And when you evaluate the negative x's, you get a total of 3 sign changes. And the polynomial is of 8th degree. So again, let's write my positive column, my negative column, my imaginary, and my total. Again, remember the first thing you always do, you always fill in the total first. You always fill in the total first. Now let's look at these examples. Now, for my positive numbers, I can either have 4 solutions. I can have I'm going to list all the possibilities. I can have 4 solutions, 2 solutions, or no solutions. Because I have to go down by 2 every single time. That's the rule we went over the other day. And when I'm looking at my negative solutions, I can either have 3 or 1. I have to go down by 2 every single time. These are all my possibilities for negative and positive solutions, or the amount of negative and positive solutions. All I have to do here is combine all my outcomes, like probabilities. I'm going to combine the 4 with the 3 and the 4 with the 1. Then the 2 with the 3 and the 2 with the 1. Then the 0 with the 3 and the 0 with the 1. So the amount of rows depends on the total possible outcomes. You can have a table with just 1 row, or with 5 rows, or 10 rows. So let's begin. I'm going to do my 4 here with my 3. If I have a total of 7 when I'm adding my positive and my negative, but I should have 8, how many imaginaries do I have? 1. Because when I add everything, I have to add 8. Now let's try the 4 with the 1. Now I have 4 positive and 1 negative. These add up to 5. But since I should have 8, the imaginary answers are 3. So I'm done with my 4. Let's go on with my 2 now. 2 and 3. These add up to 5. Since I have to end up with 8, I'm going to have 3 here. Now 2 with 1. 2 with 1 is 3. Since I have to end up with 8, this number has to be 5. So again, the imaginary depends on the total of these 2. And the total of these 2 depends on all your possible outcomes. So I already finished with my number 2. Now let's go with my 0. No positive, 3 negative. That means I have to have 5 imaginary. And no positive, 1 negative. That means I have 7 imaginary. That's it. You can have shorter tables or longer tables. You write down your possible outcomes for positive, your possible outcomes for negative. You combine them in all manners along your table, and your imaginary solutions depend on the addition of the positives and negatives. That's it. Pretty much the imaginary is what you're missing here to end up at your total. Are we clear? Hope that's clear. If you still didn't understand, please let me know. Again, even though this isn't critical for exams and such, you need to understand how the total possible outcomes are divided between imaginary, positive, and negative solutions to have a better idea of how to solve polynomials, because again, it's gonna get tricky. I did tell you guys it was gonna get trickier. Now let's go over today's actual class. Sorry, marker. There we go. Please don't throw yourself. So let's go over transformations. The first class in 10th grade was literally graphing and transformations. I told you guys we would see transformations throughout the entire year, so they're back again. But the difference is that now, instead of transforming a monomial, I might have to transform a polynomial. But again, the good thing is the exact same rules apply. The exact same rules apply. For example, when you have, let's say, f of x is your basic polynomial. Again, we're going to see a couple of examples here. If you subtract something within the parentheses, remember, that's left or right. F of x minus 5 is a transformation of 5 units to the right. Because when we're working inside the parentheses, it's opposite. Positives take you to the left. Negatives take you to the right. Profe, ¿por qué? That doesn't make any sense. Remember, the formula for transformations is this. So if you plug in a negative number, that means you're going to the left. Negative times negative is positive. You'd be looking at a positive number, but you actually plugged in a negative number. And at the same time, if you plug in a positive number, positive times negative is negative. So even though you plugged in a positive number, you're looking at a negative number. That's why it's the opposite. So that takes care of left or right. Remember, you're moving the entire polynomial left or right based on the number. Positives take you to the left, negatives take you to the right. When you add outside the parentheses, it's up or down. Positives or additions take you upward, move the entire polynomial upward. Negative numbers, move it downward. Now, when we began, we only focused on this one, reflecting across the x. Now we're gonna plug in this one, which is reflection across the y. The difference is, if you change the sign inside a parenthesis, this is not the same thing as this. Actually, let's have a totally different outcome. Here, I'm reflecting across the y. Here, I'm reflecting across the x. Let's see how this behaves right now. Again, it's an even degree, so you know you can expect a somewhat parabolic shape. Okay, but let's look what happens here. If I were to do PEMDAS, I would do the exponent first and negative x to the 4th degree. After I simplify that, I end up with this, because again, this turns positive. And what do I end up with? Something that looks like a normal parabola that hasn't been reflected. Why? Because if you reflect a parabola across the y, it pretty much stays in the exact same spot and just flips. Now let's see what happens here. Ayana wants to join the math class, but she can't yet. Let's see what happens here. PEMDAS, you raise this to the 4th degree, you end up with x to the 4th degree positive. And when you apply the negative, you actually end up with a reflected parabolic shape. So again, when the negative is on the outside, it's reflection across the x. Up or down, up or down. When it's inside the parentheses, it's reflection across the y. Left or right. Everything within the parentheses affects it in a horizontal fashion, left or right. Everything outside, up or down. So again, left or right, reflecting left or right or across, and as we'll see later, horizontal stretches and such. Now, again, that takes care of reflections across the x and reflections across the y. Let's look at these examples right now. Also, when we began chapter 10, because I didn't want to confuse you guys too much, we only focused on vertical stretches. I said whenever we multiply, vertical Whenever we multiply by a number bigger than 1, it's a vertical stretch. Whenever we multiply by a number smaller than 1, it's a vertical shrink. Now we need to differentiate vertical with horizontal. Again, in the exact same manner, since I'm multiplying inside the parentheses, that would be a horizontal stretch or shrink. Since you're multiplying outside, or you're multiplying your answer, it would be a vertical stretch. Now the thing is, much like your transformations, inside the parentheses is opposite, it's also opposite here. What that means is, if you actually multiply inside the parentheses by a number bigger than 1, instead of what happens normally, which is a vertical stretch, you get a vertical stretch. Since it's inside the parentheses, it's horizontal. And since it's the opposite, instead of a stretch, this would be a horizontal shrink. Likewise, if you multiply inside the parentheses by a value between 0 and 1, if this were outside, it would be a vertical shrink. But since this is inside the parentheses, it's a horizontal stretch. Again, it's the opposite. Outside the parentheses, vertical. Inside the parentheses, horizontal. Outside the parentheses, bigger than 1, stretch. Inside the parentheses, bigger than 1, shrink. Outside the parentheses, smaller than 1, vertical shrink. Inside the parentheses, smaller than 1, horizontal stretch. It's the opposite. Now that we have the theory down, let's go over a couple of examples. Let's go over examples 3. Example 3, they're giving me this polynomial. For example, they're giving me that particular polynomial. And they're telling you, describe the following transformations. And they tell you that g of x, Prophet, why is that a g? Because it's f of x transformed. So they tell you what would happen if I were to do this to this polynomial. And all you have to do is substitute your x for this x. And I would have something that looks like this. Again, similar to what we did in Descartes' rule of signs. Now we apply PEMDAS. Negative to an odd degree, I end up with a negative number. Negative to an even degree, I end up with a positive number. Positive times positive, positive, plus 1. And pretty much that's it. Now, let's go over what happens with a second example. They tell you that g of x, which is a transformed f of x, equals 3 f of x. Now, when you have this particular expression, all you have to do is open a parenthesis, plug in your polynomial inside the expression, and put the 3 in front of it. Again, we mostly did this with monomials at the beginning of the class, but now we're going to be working with polynomials. You distribute, and you're left with 3x cubed plus 3x squared plus 3. Same thing with vertical stretches, examples 4. Again, you can look at those examples and just, do what they're asking you to do. Also, if they tell you, for example, if they tell you x squared plus x plus 3, and they tell you f of x plus 2, open a parentheses, add 2, open a parentheses, add 2, and then you just, all you have to do is manipulate your polynomial with the instructions they're giving you here, and you're done. That's it. So right now, let's go over the homework, which again, remember, it's the first grade of the 4th quarter. I will be giving these grades a lot of weight, so make sure you take the job seriously. If I do a quiz, or when I do a quiz, take note that it's not going to be a group quiz, which everybody will have an entire hour to answer, and you can, work in groups and such. No, when I give you the quiz, I'm basically going to give each student about 6 to 8 minutes to do the exercises in front of me via Skype individually. And I'm going to do that for every student, 1 or 2 questions. So don't think that you can just copy the test and then I'll send a quiz, or copy the homework, I'll send the quiz. You'll just, group chat with house party and just say, hey, everybody, the first one is 4. No, it's not going to be like that. So make sure you study individually. I will announce the quizzes, which there will be about 2 days in advance. So make sure you schedule the Skype use properly, or at least have your phone charged. I don't want any excuses the day of the quiz. You don't show up to the quiz at your time slot, you fail. You don't end the quiz in the time slot, you're done. I can't give you more time because I'm going to be on a very tight schedule and everybody's going to be waiting for their turn. So make sure you practice these examples and you do not waste time. Are we clear? So for homework, make sure, let's do 3 to 6. Here, all you have to say is describe the transformation. You do not have to graph. Do not graph. Just describe the transformation. It went 5 down. It went 3 to the left. It's got a horizontal stretch by a factor of so much. So now remember, you do have to be very clear on horizontal manipulations. Horizontal versus vertical. So you're going to do 3 through 6. And also you're going to do 11 through 16, which is the exact same thing. Describe the transformations. And you're going to do 17 through 20. When they tell you write a rule, that means do what we just did. If they give you, for example, a squared plus x plus 1, and they tell you write a rule for x minus 4, you're just going to x minus 4 squared plus x minus 4 plus 1. So the new transformed polynomial is the rule I'm looking for. If you have any questions, please send them via private chat or upload or just question answer forum. And for the 3rd grade's quarter, remember, I never give extra credit. Extra credit does not exist in my vocabulary, even though I just said it. It does not exist. I don't know how I'm saying that word because it doesn't exist in my vocabulary. I give you guys the curve. I give you guys fair exams. I expect you to study. No extra credit ever. Now, since this is a very particular situation and we kind of missed out on 1 or 2 more, or 1 test in class, I'll talk to my boss to see, or Lucy, to see if we can maybe add an extra grade or not. But don't count on it. Don't count on it. Always count on doing your work properly. If you get a little bonus at the end, awesome. If not, you did your job properly. Okay? So take care and I'll talk to you soon.